As we begin looking at surface area, we want to start by thinking about the nets of 3D objects. And you probably remember doing this in school quite a bit. It's when you take a 3D object, just like it's happening in this video right here, and you open it up so it is flat and two-dimensional. And that shape there is the net of the object. So that's what a rectangular prism would look like if you opened up the net of it. And then over here is what a cylinder would look like if we opened up the net of that. So here, let me just open it like this and so on. So it has two circles and then one big rectangle, and that makes the cylinder. So to find the surface area of these three-dimensional objects, what we're actually doing is we're finding the area of every single 2D shape in the net. So for the cylinder, we would find the area of both of these circles, and then we'd also find the area of that rectangle, and we'd add them all together, and that would give us the surface area of the cylinder. And same thing goes for this rectangular prism. We would find the area of every single one of those rectangles in the net, and that would make the surface area of the entire rectangular prism if we added them all together. So let's take a look at our notes here. We're going to skip this first one over here because it requires you to have an object, but we'll head into this one. So in this question, they want us to find the total surface area of this wooden cabinet that we could see off to the side over here. And to start that, we're going to look at the net of the object. So they started laying this out for us here. They flattened this wooden cabinet into the net. So let's plug in some of these measurements. Now let's start off with the outside measurements, and then we can find the area of every one of these. So if we're looking at the outside measurements where the blanks are, I know that I'm going to have to put a 24 over here because it matches the same length as this side. I can also see that in this blank over here, a 48 goes because this side over here is 48, and that means this one up here is also 48. And then we're also looking at the smaller blanks here, and the only number we haven't used yet is 16. So this blank here is 16. This one here is 16. This one here is 16. So we have all of the dimensions of each one of these rectangles. Let's find the actual area. So I'm going to zoom in here before we do that. So if we're looking at the area of this top one, they already plugged in a lot of the information for us. 16 times 24, so that is the length and width of that rectangle. So if we do that in our calculator, we are going to get 384 square inches. So I need to turn my tablet to the side. The area of this one I'm working on now, we're going to be doing 16 inches. So that's the length over here, and the width would be 48. If you switch around these two numbers and do 48 times 16, that is okay as well. So then we would have 768 inches squared, or square inches. And while my tablet's turned, I'm going to do this one over here. We have 16, which is this side, and this one over here would be 48 once again. So this is going to be the exact same as the last one we did, 768 inches squared. And now we can work on these other ones. This bigger one here, we would have 24 times 48. And if we plug that into our calculator, we're going to get 1,152 inches squared. And this one over here is going to be the exact same size, 24 times 48, which is 1,152 inches squared. And this one, finally, is the exact same as this one up here. So we're going to do 16 times 24, which is 384 inches squared. So now if we're finding the total surface area of this cabinet, we need to add up all of the areas that we found in the net here. Now, each one that we looked at had another side that matched it exactly. So for instance, this one here matches exactly with this one here. And then if we're looking more, we said that this one down here matched with this one up here. And finally, this one here matches with this one here. So when we find our total, we can take one of those areas and times it by 2, which is what they're doing in the formula over here. So we're going to plug in the area of one side and then we're going to times it by 2 because there's a matching pair of them. So let's start off with the ones I did in yellow. So the area of one of those we got was 1,152, and then we're going to times that by 2 because there's one side here and one side here that matches. Next, let's look at these ones here. So we would have 2 of them that are 384 inches squared. And then finally, we'll look at the orange starred ones, 2 of them that are 768 inches squared. So now if you know how to use your calculator, you could just plug this in all at once. I like to follow BEDMAS and do my multiplying first. So I'm going to do 2 times 1,152. That gives me 2,304. Then I'm going to add that to 2 times 384, which is going to give us 768. And then we're going to add that to 2 times 768, which gives us 1,536. So if we add all of those together, the total surface area is 4,608 square inches, or inches squared. Either one of those works. And like I said, we're going to skip over this one here. We could just put a nice big X over it. It just gets a little bit too confusing. So now let's look at an example with a cylinder. So like I showed you at the very start there, we have 2 circles and we have a big rectangle. And if we were to make this into a 3D object, it would be a cylinder. So the North End Water Pollution Control Center in Winnipeg has cylindrical tanks. Bacteria in the tanks clean wastewater. Each tank has a radius of 16.5 meters and is 8.6 meters high. So let's plug in these numbers while we're on the topic. So each tank has a radius of 16.5, and you'll see here they have the radius labeled for us. So I'm going to put 16.5 here and 16.5 here. Now it also says that the tank is 8.6 meters high. So imagine that this net here was closed into the 3-dimensional object. The height of it would be this small side here on that rectangle. So the height is actually over here. So we're going to plug in 8.6 meters. Maintenance staff paint the tops and sides of the tank. What surface area needs to be painted for each tank to the nearest square meter? So let's figure out the surface area of this tank. So we already labeled the tanks with the measurements that we saw. So let's move on to B. Now let's start off with finding the circumference of the top of the cylinder. Now remember, the circumference is the distance all the way around a circle. And this measurement here is going to help us with the surface area, and we'll see that in the next step. So the formula for circumference was pi times 2 times the radius. So in this case, pi times 2 times 16.5. And if we plug that in our calculator, we get 103.672 meters. Now it says, what part of the rectangle has the same measurement as the circumference of the circle? So imagine that little diagram I showed you, or the little animation where it was closing into the cylinder. This circumference here actually has the exact same length as this part of the rectangle, because if this were to close, this rectangle would be wrapped around the circle. It would be like over here. So we're going to put that the length of the rectangle has the same measurement as the circumference of the circle. Therefore, let's find the area of the rectangle. So the area of the rectangle is length times width. So in this case, we'll put the length here, which is 103.672. So length, and the width is 8.6. That's that measurement that we have on the side over here that they gave to us. So if we plug this into our calculator, we will get 891.583 meters squared. Next, let's look at the area of the circle. So the area of the circle is pi times radius squared. So the radius in this case is 16.5. So like I said in the previous topic, I like squaring this radius first. so we don't accidentally square the pi as well. So 16.5 squared is 272.25, or if we were to do pi times 272.25, we get 855.298 meters squared. So now let's calculate the surface area to be painted. Now keep in mind with this question, it's a little bit of a tricky one because it says that maintenance staff wants to paint the top and the sides of the tank. That does not include the bottom of it. So this circle down here is not going to be included in our surface area. So we need to add the area of the top circle plus the area of the rectangle. So the area of the top circle we got was over here, 855.298. And we're going to add that to the area of the rectangle, which we got here, 891.583. So if we add both of those together, we get 1,746.882. Or if we round that, we could say the surface area that needs to be painted is 1,747 meters squared.